Jake Martinez wiped the sweat from his forehead as he finished tightening the last bolt on the air recycling unit. The old section of Meridian Station always ran hot, and the ancient ventilation system struggled to keep up with the newer parts of the facility. He had been working in this cramped maintenance tunnel for 3 hours, replacing worn seals and checking pressure readings on instruments that most of his colleagues considered outdated junk. The space station Meridian floated 400 kilometers above Earth, spinning slowly to create artificial gravity in its outer rings. Jake loved working in the older sections where everything was mechanical and straightforward. No computer interfaces, no digital readouts that could glitch or fail. Just honest gauges with needles that pointed to numbers, valves that opened and closed with the turn of a wheel, and systems built to last decades without fancy updates. A sudden blare of alarms shattered the quiet hum of machinery. Red lights flashed in the narrow corridor, and Jake felt his stomach drop as the emergency klaxon echoed through the station. He grabbed his tool bag and rushed toward the nearest communication panel, his boots clanging against the metal deck. "Plates! All personnel report to stations immediately," crackled the voice of Commander Lisa Brooks over the intercom. "This is not a drill. Emergency protocols are now in effect." Jake made his way through the winding corridors toward the central hub, passing worried faces of crew members and civilian contractors. The station housed 43 people total, mostly engineers, scientists, and support staff working on various orbital projects. As he climbed the ladder toward the observation deck, he could hear excited voices and the rapid beeping of computer terminals. The main observation deck buzzed with activity when Jake arrived. Through the massive reinforced windows that offered a panoramic view of space and Earth below, he could see something that made his breath catch in his throat. An enormous vessel drifted silently against the starfield, easily 3 times larger than Meridian Station itself. The ship had a sleek, organic design unlike anything human engineers had ever built, with curved surfaces that seemed to flow like liquid metal frozen in space. "Holy hell," whispered Pete Johnson, the navigation specialist, as he stood next to Jake at the window. "That thing just appeared on our sensors 20 minutes ago. No warning, no communication, nothing." Jake studied the alien craft more carefully. Even from this distance, he could see damage along its hull. Scorch marks and what looked like torn metal suggested the vessel had been in some kind of battle. No lights blinked along its surface, no engine glow indicated active propulsion systems. The ship appeared completely dead in space, drifting like a massive piece of debris. Commander Brooks stood at the central command console, her face tense as she spoke rapidly into her headset. "Earth Control, we need immediate guidance on this situation. The vessel shows no response to any communication attempts across all frequencies. Repeat, no response on any channel." Carol Davis, the chief engineer, hunched over a computer terminal, displaying trajectory calculations. Her fingers flew across the keyboard as she updated the ship's predicted path. "Commander, you need to see this," she called out, her voice tight with worry. Brooks hurried to Carol's station, and Jake followed, along with several other crew members. The display showed a 3-dimensional model of Earth's orbital space, with 2 objects marked in different colors. One represented Meridian Station, the other the alien vessel. "The ship's orbit is decaying," Carol explained, pointing at the projected path. "At its current rate and trajectory, it will intersect with our position in 17 hours and 43 minutes. A collective intake of breath filled the observation deck. Jake felt his hands go cold as the implication sank in. The alien ship wasn't just drifting harmlessly through space. It was falling toward them on a collision course that would destroy both vessels and everyone aboard. "What about evacuation?" asked Danny Kim, the security officer. "How many shuttles do we have available?" "2 passenger shuttles with a maximum capacity of 12 each," Brooks replied grimly. "Even if we packed them beyond safety limits, we could maybe get 30 people off the station. That leaves more than a dozen crew members behind." Jake walked back to the observation window and stared at the alien ship. Something about its lifeless appearance bothered him. The vessel was clearly advanced technology, far beyond anything humans had achieved, yet it drifted helplessly like a sailing ship with no wind. Every human spacecraft bristled with communication arrays, sensor dishes, and navigation equipment. This ship seemed to have none of those systems active. Has anyone considered that they might be in trouble too? Jake said loud enough for the others to hear. Roy Adams, who served as the station's defensive systems coordinator, looked up from his console. What do you mean? Look at that ship, Jake continued, still gazing out the window. No lights, no communications, no course corrections. What if their systems failed? What if they're as stuck as we are? Stuck or not, that thing is going to crush us in less than 18 hours, Pete Johnson replied. We need to focus on getting our people out of here. But Jake's mind was already working on a different problem. He had spent years maintaining the older sections of Meridian, learning to work with mechanical systems that predated computer control. Those systems were considered obsolete by most engineers, backup equipment that nobody expected to use in normal operations. Yet they still functioned, still performed their jobs without digital interfaces or network connections. Commander, Jake said, turning away from the window, I need to check something in the maintenance section. There might be another option. Brooks looked at him with a mixture of hope and skepticism. What kind of option? Let me run some calculations first. I'll have an answer for you in 2 hours. Jake left the observation deck and made his way back toward the older sections of the station. His mind raced with possibilities as he navigated the familiar corridors. The alien ship might be technologically superior, but it was still bound by the same laws of physics that governed all objects in space. Mass, velocity, trajectory, momentum. These were universal constants that didn't care about the sophistication of the systems controlling them. In his workshop, surrounded by spare parts, manual tools, and analog instruments that most people considered museum pieces, Jake began pulling out equipment he hadn't used in months. Slide rules, mechanical calculators, paper charts showing orbital mechanics equations. The tools looked primitive compared to the computer systems that ran most of the station, but they had one crucial advantage: they couldn't be hacked, couldn't suffer system failures, and didn't depend on power grids or network connections. As Jake spread the charts across his workbench and began making calculations with tools that belonged to an earlier era of space exploration. He wondered if humanity's old-fashioned approach to problem-solving might succeed where advanced alien technology had apparently failed. The universe operated on mathematical principles that remained constant regardless of species or civilization level. Outside his workshop window, the alien ship continued its silent drift toward disaster, carrying unknown lives that depended on solutions no computer had yet calculated. Jake worked through the night with his analog instruments spread across every available surface in his workshop. The mechanical calculator clicked and whirred as he fed numbers into its brass gears, while his slide rule helped verify calculations that most engineers would run through computer programs. On paper charts marked with pencil lines and eraser smudges, he mapped out trajectories and force vectors that could change the course of both vessels. The math was simple in principle but complex in execution. Every object in space followed predictable paths based on mass, velocity, and gravitational influences. The alien ship, despite its enormous size, was essentially a projectile following the laws of physics. If Jake could apply force at the right angle and timing, he might be able to nudge its trajectory enough to avoid collision with Meridian Station when the morning shift began. Jake had filled 17 pages with calculations and sketched out a plan that seemed impossible at first glance. He gathered his papers and headed to the senior staff meeting that Commander Brooks had called to discuss evacuation procedures. The conference room felt cramped with all department heads present. Carol Davis sat next to Chief Medical Officer Ben Taylor, while Security Officer Danny Kim reviewed passenger manifest lists with Communications Specialist Amy Foster. Everyone looked tired and worried as they discussed the grim mathematics of limited shuttle capacity. We can modify the cargo bay to hold additional passengers, Carol was saying as Jake entered the room. It won't be comfortable, but we might squeeze in 5 more people per shuttle. That still leaves 8 crew members behind, Brooks replied. I won't ask for volunteers for a suicide mission. Jake cleared his throat and placed his stack of papers on the conference table. Commander, I think there might be another way. The room fell silent as everyone turned to look at him. Jake had never been comfortable speaking to groups, preferring the quiet solitude of his maintenance work, but desperation gave him courage. What if we don't abandon the station? Jake continued. What if we use Meridian itself to change the alien ship's course? Roy Adams laughed, but there was no humor in the sound. Jake, that ship has a mass of at least 50,000 tons. Our positioning thrusters couldn't budge something that size. Not the positioning thrusters, Jake said, opening his folder and spreading calculations across the table. The construction bay mechanical systems. The grappling arms designed for assembling large structures. The mining equipment we use for asteroid processing. Carol Davis leaned forward to examine Jake's handwritten equations. You want to physically grab an alien spacecraft with construction equipment? The ship appears to be dead in space, Jake explained, pointing to his trajectory charts. No active propulsion, no maneuvering capability. It's following a ballistic path that we can calculate precisely using these analog instruments. He tapped his slide rule against the table. If we can attach to the vessel at the right point and apply force in the correct direction, we can alter its course just enough to avoid collision. Ben Taylor shook his head. Jake, that's incredibly dangerous. We have no idea what that ship is made of, what systems might still be active, or how it would react to physical contact. It's more dangerous to do nothing, Jake replied. In 15 hours, that ship will hit us whether we like it or not. At least this plan gives us a chance to survive. Commander Brooks studied the calculations, her finger tracing the penciled lines on Jake's charts. Walk me through this step by step. Jake moved to the room's whiteboard and began sketching diagrams with a marker. First, we used the station's maneuvering thrusters to adjust our position slightly. Not much, just enough to bring us into optimal contact range with the alien vessel's most stable section. He drew 2 circles representing the ships and added arrows showing their paths. Next, we deploy the construction bay's mechanical grappling system. These arms were designed to manipulate objects weighing thousands of tons during station assembly. They operate on hydraulic pressure and manual controls, completely independent from computer systems. Amy Foster raised her hand. What about the aliens? If there are survivors aboard that ship, they might not appreciate us grabbing them with giant mechanical claws. That's a risk we have to take, Jake admitted. But if they're truly stranded with failed systems, they might welcome any attempt at rescue. The alternative is that we all die when the ships collide. Danny Kim studied the trajectory projections. How precise do these calculations need to be? What's the margin for error? Jake returned to his papers and pulled out a sheet covered with timing calculations. We have approximately a 4-minute window to make contact and begin applying force. Too early and we don't have enough leverage. Too late and there isn't enough time to change the ship's momentum. And the force application has to be sustained for at least 12 minutes to achieve the necessary course correction, Jake continued. During that time, both ships will be locked together and subject to tremendous stress. Carol Davis was already thinking through the technical challenges. Our construction systems weren't designed for this kind of operation. We'd need to bypass safety protocols, override automatic shutoffs, and operate everything manually. Exactly, Jake said. That's why we need the analog backup systems. Computer-controlled operations would be too slow and might fail at critical moments, but mechanical controls respond instantly to human input. Brooks stood up and walked to the observation window where the alien ship was now clearly visible as a dark shape against the star field. You're asking us to bet everyone's lives on equipment that most people consider obsolete. I'm asking us to bet our lives on human engineering and problem-solving, Jake replied. Those mechanical systems were built to last and built to work under extreme conditions. They've never failed us before. The room remained quiet for several long moments as everyone considered the implications. The plan was risky beyond measure, requiring precise timing and flawless execution with no room for error. Yet it offered something that evacuation could. Not the possibility that everyone might survive. "What do you need from us?" Brooks finally asked. Jake felt a surge of relief mixed with terror. "I need volunteers who can operate mechanical systems without computer assistance. People who understand manual controls and aren't afraid to work with their hands when everything depends on split-second timing." Steve Parker, a maintenance worker who had been quiet throughout the meeting, spoke up. "I've worked with the construction bay equipment. It's all hydraulic and cable-driven. No computers needed once you understand the mechanical principles." "I can handle the mathematical calculations in real time," added Pete Johnson. "If Jake shows me how to use those analog instruments, I can provide navigation updates throughout the operation." One by one, other crew members volunteered for different aspects of the plan. Amy Foster offered to coordinate communications using the manual radio systems. Carol Davis volunteered to oversee the mechanical modifications needed to prepare the construction bay. Even Ben Taylor, despite his medical training, offered to help with whatever tasks required steady hands and calm nerves. As the meeting broke up and crew members hurried to their assigned preparations, Jake remained in the conference room staring at his calculations. In 13 hours, they would either achieve something unprecedented in human space operations or die trying. The success of their mission would depend entirely on analog technology and human determination, two things that had served their species well long before computers existed. Jake stood in the construction bay watching his team prepare the mechanical grappling system for an operation it was never designed to perform. Steve Parker crawled beneath the massive hydraulic arm assemblies, checking fluid pressure lines and testing manual control responses. The bay echoed with the sounds of wrenches against metal and the hiss of pneumatic tools as they bypassed computer interfaces in favor of direct mechanical operation. "Hydraulic pressure is steady at 3,000 psi, Steve called out from beneath the primary grappling arm. "All manual controls are responding normally. We're as ready as we're going to get." Carol Davis emerged from the control booth wiping grease from her hands. "I've disconnected all automatic safety systems and computer overrides. From this point forward, everything operates on direct human control only. No computer assistance, no automated shutdowns, no digital safeguards." Jake nodded and checked his analog chronometer. 9 hours until contact window. That gives us time to run through the procedures one more time and make sure everyone understands their role. The construction bay had been transformed into something resembling an old-fashioned machine shop. Analog gauges replaced digital displays, mechanical switches substituted for computer controls, and handwritten charts covered every available wall surface. It looked primitive compared to the sleek technology that normally operated the bay, but Jake felt more confident working with systems he could see and touch. Amy Foster arrived carrying a large case filled with portable radio equipment. "I've got the manual communication system set up. We can maintain contact throughout the operation without depending on the station's computer network." "Good," Jake replied. "We need to establish timing coordination between all positions." "Pete, how are the navigation calculations coming?" Pete Johnson sat at a desk covered with mechanical calculators, slide rules, and hand-drawn charts. "I've got the alien ship's trajectory plotted down to the minute. As long as nothing changes, we'll have our contact window exactly as predicted." The work continued through the day as each team member mastered their assigned analog systems. Jake moved between stations, checking progress and answering questions about mechanical operations that most of his colleagues had never performed manually. The old skills that had made him valuable in maintaining the station's obsolete sections now became critical knowledge for everyone's survival. Late in the afternoon, something unexpected happened. Amy Foster was monitoring radio frequencies when she noticed an unusual pattern in the background static. "Jake, you need to hear this," she called from her communication station. Jake put down his wrench and walked over to where Amy sat wearing headphones connected to the manual radio receiver. She adjusted the frequency dial and pointed to a needle gauge that showed signal strength. "There's a pattern here," Amy said. "It's faint, but it's definitely artificial. Listen." Jake put on the spare headphones and heard what sounded like random static at first. But as he listened more carefully, he began to detect a subtle rhythm in the noise. Short bursts followed by longer ones, with pauses that seemed too regular to be natural interference. "It's coming from the direction of the alien ship," Amy continued. "I think someone over there is trying to communicate." Pete Johnson looked up from his calculations. "What kind of signal pattern?" Amy grabbed a pencil and paper, marking dots and dashes as she listened to the transmission. Short pulse, long pulse, pause, then 3 short pulses, pause, then 5 short pulses, pause. 2, 3, 5, Pete said immediately. "Those are prime numbers. That's not random." Jake felt his heart rate increase. "Keep listening. See if the pattern repeats or continues." For the next 20 minutes, Amy transcribed the signal while Pete identified the mathematical sequence. 7, 11, 13, 17. The aliens were broadcasting prime numbers in order, a clear indication of intelligence and mathematical understanding. "They're alive over there," Jake said with growing excitement. "And they understand basic mathematics." Carol Davis joined them at the communication station. "Can we respond? Do we have enough power to reach them?" Amy checked her equipment and adjusted several manual controls. "I can boost the signal strength, but I need to know what to send." Jake thought for a moment, then grabbed the pencil from Amy. "Start with the same sequence they sent, prime numbers 2 through 17. Then add 19, 23, and 29. If they're really listening, they'll recognize that we're continuing their pattern." Amy carefully transmitted the number sequence using short and long radio pulses. The construction bay fell silent except for the clicking of the transmission key and the hum of analog equipment. Everyone waited, watching the signal strength meter for any response. The alien reply came within minutes. The same prime number sequence, but this time continuing further, 31, 37, 41, 43. Then something new, a different pattern that Pete immediately began analyzing. "They're sending coordinates," Pete said, his excitement growing. "Spatial coordinates relative to their ship's position. I think they're telling us where to make contact." Jake studied the numbers Pete had written down. The coordinates pointed to a specific section of the alien vessel, roughly midway along its hull where the structure appeared most intact. It was remarkably close to the contact point Jake had calculated for optimal force application. "They understand what we're trying to do," Jake realized. "They know we're planning some kind of rescue operation, and they're helping us target the right location." Over the next several hours, the mathematical conversation between the two ships grew more sophisticated. The aliens provided structural information about their vessel, indicating which sections were stable and which areas to avoid. They shared mass distribution data that allowed Pete to refine his trajectory calculations. Most importantly, they confirmed that approximately 200 individuals remained alive aboard their ship. The aliens also revealed something troubling. Their transmissions included a pattern that Pete interpreted as a countdown, a steadily decreasing number that corresponded to their ship's structural integrity. The vessel wasn't just drifting helplessly. It was actively breaking apart. Sections were losing atmosphere, and hull breaches were expanding with each passing hour. "We're not just trying to avoid a collision anymore," Pete explained to the assembled team. "We're conducting a rescue operation. If we don't succeed, those aliens are going to die when their ship comes apart." Jake felt the weight of responsibility settle on his shoulders. 200 alien lives now depended on their analog technology and mechanical systems, working perfectly under conditions they were never designed to handle. The mathematical conversation had transformed their mission from simple survival to an act of interspecies cooperation. "Final equipment check," Jake announced. "We go operational in 4 hours. Every system needs to respond flawlessly because we won't get a second chance." As his team returned to their preparations, Jake looked through the construction bay windows at the alien ship, now close enough to see individual hull features. "Somewhere aboard that damaged vessel," Intelligent beings were waiting for rescue by a species they had never met. Trusting their lives to human engineering and determination, the universe had presented humanity with its first contact scenario, and it would be resolved not by diplomats or advanced technology, but by mechanics with slide rules and the courage to attempt the impossible. Jake strapped himself into the manual control seat as the final hour approached. The construction bay hummed with tension as his team took their positions at analog stations throughout the facility. Through the reinforced windows, the alien ship now filled much of their view, its damaged hull revealing gaping holes where atmosphere and debris continued to vent into space. Radio contact established, Amy Foster reported from her communication station. The aliens are standing by and ready to assist with docking procedures. Pete Johnson sat hunched over his mechanical calculator, updating trajectory calculations every few minutes as new data came in. Contact window opens in 57 minutes. The alien vessel's rotation has stabilized, but we're seeing increased debris separation from the aft sections. Jake tested the manual controls one final time. The grappling system responded to his touch like a massive extension of his own hands. Hydraulic pressure gauges showed green across the board, and mechanical linkages moved smoothly through their full range of motion. Everything depended on these analog systems, working perfectly under conditions that would have destroyed computer-controlled equipment. "Commander Brooks to construction bay," crackled the voice over the manual radio system. "Earth control is demanding we abort this operation and proceed with evacuation. They're calling it too dangerous to attempt." Jake keyed his microphone. "Commander, we're past the point of safe evacuation. The alien ship's debris field has made shuttle operations impossible. Our only choice is to complete the rescue or wait for both ships to be destroyed." Through his headphones, Jake could hear heated discussions taking place on the command deck. Earth-based mission control wanted them to abandon the plan and attempt emergency evacuation despite the risks. Local commanders understood that circumstances had moved beyond conventional options. The decision ultimately rested with Commander Brooks, who had to choose between following orders from 400 kilometers away or trusting the judgment of people who could see the situation firsthand. "Construction bay, you are authorized to proceed," Brooks finally announced. "God help us all." Jake felt his stomach tighten as he began the final approach sequence. The alien ship loomed larger in the windows, its hull showing details that no human had ever seen before. Strange symbols were etched into the metal surface, and what appeared to be viewing ports suggested internal spaces designed for creatures unlike anything on Earth. 30 minutes to contact," Pete called out, adjusting for the alien vessel's latest position update. The mathematical conversation with the aliens had grown more urgent as structural damage continued to worsen aboard their ship. They reported complete failure of their primary life support systems and were now surviving on emergency reserves that would last only a few more hours. More critically, their hull integrity was failing faster than initially calculated. "They're telling us something new," Amy said, listening intently to the latest transmission. "The pattern is different." Pete analyzed the incoming numbers and his face went pale. "They're evacuating their outer sections. They're deliberately venting atmosphere from damaged areas to reduce mass and debris." Jake realized what this meant. The aliens were sacrificing parts of their own ship to make the rescue operation safer for both species. Sections of their vessel that might have contained survivors were being abandoned to improve the chances of saving the majority. It was an act of calculated courage that any human would recognize and respect. "Contact in 15 minutes, Pete announced. "All systems show ready." Jake began the delicate process of maneuvering Meridian Station into position for the grappling operation. The station's positioning thrusters responded to manual commands, nudging the massive structure toward an intercept course with the alien vessel. Every movement had to be precise because they would only get one opportunity to make contact. Through the construction bay windows, Jake could see the alien ship's hull approaching. The section they were targeting appeared structurally sound, with what looked like reinforcement ribs running along its length. The aliens had guided them to a docking point that could withstand the stress of mechanical contact and force application. 5 minutes to contact, Pete called out. Relative velocity is within acceptable parameters. Jake's hands moved across the manual controls with practiced precision. The primary grappling arm extended slowly, its massive claws opening to embrace a section of alien hull. Hydraulic systems responded instantly to his commands, with no computer delays or automatic safety interventions to complicate the procedure. Contact. In 60 seconds, Jake announced. All stations prepare for mechanical connection. The alien ship filled the construction bay windows completely now. Jake could see individual hull plates, structural details, and what appeared to be damage from weapons fire. The vessel had clearly been in a battle before arriving at Earth, and its crew had been struggling to survive ever since. 30 seconds. To contact, Pete said, his voice tight with concentration. Jake held his breath as the grappling arm approached the alien hull. The claws were designed to grip construction materials and asteroid fragments, but they would have to adapt to an alien ship's architecture. Everything depended on the fundamental assumption that physics worked the same way for all intelligent species. Contact, Jake said as the grappling arm touched the alien vessel. The impact sent vibrations through both ships, but the alien hull held firm under the mechanical pressure. Jake began closing the grappling claws, feeling the resistance. As they bit into the strange metal surface, pressure gauges showed the clamps achieving full grip strength without apparent damage to either the human or alien vessel. We have solid mechanical connection, Jake reported. Beginning force application sequence. This was the critical moment, when theory would meet reality. Jake engaged the hydraulic systems that would push both ships away from their collision course. The mechanical advantage of the grappling system had to overcome the alien vessel's enormous momentum and change its trajectory enough to avoid disaster. Force application steady, Steve Parker called from his monitoring station. Hydraulic pressure holding at maximum safe levels. Jake could feel the tremendous strain as both ships fought against their orbital momentum. Metal creaked and groaned under forces that tested every structural component to its limits. The analog gauges showed pressures approaching redline levels, but the mechanical systems continued to function exactly as designed. We're getting course change, Pete announced with excitement in his voice. Small but measurable. The alien ship's trajectory is shifting. Through the construction bay windows, Jake could see that their desperate plan was actually working. The alien vessel was slowly changing direction as human mechanical systems applied. Raw force to overcome the laws of orbital mechanics, it was. Humanity's simplest technology succeeding where advanced alien systems had failed, but success came with a price. Warning lights began flashing throughout the construction bay as structural stress reached dangerous levels. Both ships were being pushed beyond their design limits, and something was going to give way soon. Jake gripped the manual controls as warning alarms filled the construction bay. Metal groaned under impossible stress while both ships fought against the forces trying to tear them apart. The grappling system held firm, but pressure readings showed they were operating far beyond safe limits. Something had to give way soon, and Jake prayed it would not be the connection between the vessels. Trajectory change confirmed, Pete Johnson shouted over the noise of stressed metal and hydraulic systems. We're achieving the course correction, but barely. Through the construction bay windows, Jake could see pieces of debris breaking away from both ships as the mechanical stress took its toll. The alien vessel's damaged sections were shedding fragments that sparkled in the sunlight like deadly confetti. Meridian Station's older hull plates buckled under loads they were never designed to handle. Hydraulic pressure dropping in arm number 2, Steve Parker called from his monitoring station. We're losing fluid somewhere in the system. Jake felt sweat running down his face as he tried to compensate for the failing hydraulic line. The analog gauges showed pressure fluctuations that threatened to break their grip on the alien ship. If they lost mechanical connection now, both vessels would return to their collision course with no time left for another attempt. Amy, tell the aliens we need them to help stabilize their ship, Jake said into his microphone. any maneuvering capability they have left. Amy Foster transmitted the request using their mathematical code, and the response came back immediately. The aliens reported that they were venting atmosphere from strategic locations to create crude thrust, trying to assist with the course change. It was a desperate measure that used their life support reserves as improvised propulsion, but every bit of help mattered. Course change accelerating, Pete announced. The combined effort is working. Jake felt a surge of hope as the trajectory calculations showed improvement. Human mechanical systems and alien ingenuity were achieving what neither species could accomplish alone. The mathematical principles that governed orbital mechanics remained constant across the universe, but it took cooperation between two different approaches to engineering to solve the problem. Suddenly, a new alarm sounded from the communication station. Amy looked up from her radio equipment with alarm on her face. Jake, the aliens are reporting catastrophic hull failure in their forward sections. They're losing structural integrity faster than expected. Through the windows, Jake could see that large pieces of the alien ship were breaking away from the main hull. The vessel was literally coming apart under the stress of the rescue operation. They had succeeded in changing its course, but the ship might not survive long enough for the rescue to matter. How much more time do we need? Jake asked Pete. 2 more minutes of sustained force application to achieve stable orbit, Pete replied, checking his calculations frantically. But I don't think their ship can hold together that long. Jake made a decision that would have horrified safety engineers, but felt right to everyone in the construction bay. Instead of reducing stress on the failing alien vessel, he increased the force application to maximum levels. The hydraulic system screamed in protest and warning lights flashed throughout the bay, but the grappling arms held firm. All power to the mechanical systems, Jake ordered. We finish this now or we all die together. The alien ship responded to the increased force with a course change that exceeded all their calculations. The massive vessel swung away from its collision trajectory and began following a new path that would carry it safely past Meridian Station. But the price of success was becoming apparent as more sections of the alien hull broke away and drifted into space. Trajectory achieved, Pete announced with excitement and relief. Both ships are now on stable, non-intersecting orbits. Jake began the careful process of disengaging the grappling system. The mechanical claws released their grip on the alien hull, and the two vessels slowly separated. Through the construction bay windows, he could see the alien ship drifting away on its new course, damaged but intact enough to sustain life for its remaining crew. Amy, send them a message, Jake said. Tell them the immediate danger is over and ask about their status. The response came back quickly, and Amy smiled as she translated the mathematical patterns. They're reporting successful course change and expressing gratitude. They want to know if we can assist with long-term survival until rescue arrives. Jake looked around the construction bay at his exhausted team. They had just accomplished something unprecedented in human history, using analog technology and mechanical systems to save 200 alien lives. But the mission was far from over. The alien ship was still damaged, still losing atmosphere, and still carried survivors who needed help. Commander Brooks, this is Construction Bay, Jake said into his radio. Request permission to begin rescue. Operations for alien survivors. The response came immediately. Permission granted, Jake. Earth Control is sending emergency support vessels, but they won't arrive for 6 hours. Do whatever you can to help those people. Over the next several hours, Jake's team worked with the aliens to establish a more permanent solution. Using mathematical communication, they learned about alien physiology, atmospheric requirements, and technology that could be adapted to human systems. The aliens in turn shared knowledge about advanced materials and engineering techniques that could help repair damage to both vessels. The first physical contact between humans and aliens occurred when Jake manually operated the construction bay's airlock to create a temporary connection with the alien ship. The moment he opened the inner door and saw creatures from another world waiting on the other side, he felt the weight of history settling on his shoulders. The aliens were unlike anything human science had imagined, but their gestures of gratitude were unmistakable. They had survived because a human engineer chose to trust analog technology over advanced computers, and because both species understood that cooperation could overcome seemingly impossible challenges when Earth's rescue ships finally arrived. They found a remarkable scene. Meridian Station and the alien vessel were connected by temporary structures built from construction materials and salvaged components. Human and alien engineers worked side by side, sharing knowledge and solving problems that neither species could have handled alone. Jake stood in his workshop, now expanded to accommodate alien colleagues who were learning to use slide rules and mechanical calculators. The tools that his fellow humans had considered obsolete were now being studied as examples of reliable backup technology that could function when advanced systems failed. The alien refugees shared crucial information about digital warfare techniques that had disabled their ship, providing Earth with advance warning about new forms of conflict. In exchange, human engineers taught their rescuers about mechanical redundancy and manual operation procedures that alien civilization had abandoned centuries ago. As Jake watched humans and aliens working together with analog instruments that predated computer systems, he realized that intelligence and determination mattered more than technological sophistication. The universe operated on mathematical principles that remained constant across species and civilizations. But it took courage and cooperation to apply those principles when everything else failed. The first chapter of human-alien relations had been written not by diplomats or advanced technology, but by mechanics with slide rules and the determination to attempt the impossible when lives depended on success.